Okay, a series RCL circuit contains a 5.1 microfarad capacitor and a generator whose voltage is 11 volt. At a resonant frequency of 1.3 kHz, the power dissipated in the circuit is 25 watt. Calculate the inductance, resistance, power factor when generator frequency is 2.31 kHz. Okay, if you look at here, we have two type of frequency. The most important part for this question is here it says resonant frequency. That's very important. Resonant frequency. So this is the frequency at resonant. Okay, what is resonant frequency? I hope you can review back my video when I talk about resonant frequency. Yeah, when I talk about resonant frequency, this one, resonance. And talk about resonant frequency, this thing will happen. XL equal to XC, cut off, the R becomes Z, and then the phase angle becomes 0 degree, and then the power factor cos phi become equal to 1 because it's cos 0 equal to 1, cos phi equal to 1. This resonance happen at resonance, and at resonance the impedance is the lowest, minimum impedance, and the current is maximum. Okay, current maximum, lowest impedance. Yeah, so okay, review back my video and then you can do it. Yeah, so you have two type of frequency here. One is 1.3 and then another one is 2.31 kilohertz. This one is just frequency, not the resonant frequency. This one is just normal frequency. So for this frequency is not resonant. Yeah, this one is not resonant. Okay, it's not resonant. So for this one is another question. Yeah, is this for question C is not resonant. For the question itself is in resonance, but for C is not resonant. Okay, this is another frequency already. Okay, so now okay, and then you need to identify what kind of circuit is this. Yeah, it is a RCL circuit. This is important, RCL circuit. So this is a RCL circuit. So it has everything. Okay, it has everything. All component. It has all components. Okay. This is another thing you need to pay attention. RCL circuit. Okay. Sorry. So when saying that it is an RCL circuit, that means it is you know, it has everything. It has everything. It has R, yes, XL, yes, XC, yes, everything. Yes, the resistor at the x-axis, yes, the XL at the top, yes, XC at the bottom. So this RCL circuit. Okay, yes, all the arrows. Okay, and then here he give you the capacitance. You see, farad is capacitance. Farad is capacitance. Farad is capacitance. Not the XC, not the XC, not the capacitive reactance. Not this one, because this one is in ohm, unit ohm. This one is capacitance because in farad. Understand? You need to change the microfarad into farad for SI unit. Okay, you get a capacitor already, and then this generator is called you can say this is the supply or the source. Understand? Generator, this is the source of voltage or supply of voltage. So he say generator or the source, generator means supply or source. Okay, and then he say the voltage. This is voltage for who? Voltage for supply or voltage for source. Okay, and then you see here, this what voltage is this? Is the peak voltage or root mean square voltage? Again, this one not specify. It didn't specify root mean square value or peak value. Not specify means it is root mean square default value. because he did not specify, so means it is root mean square value default. Okay, so how to write this? We normally write it as this 11 volt, we write it as root mean square value for voltage. But another thing is this VRMS for who? For generator, for source. We need to bracket it. We need to write bracket VRMS for source. Why we need to bracket source? Because we have other voltage. We have voltage for VRMS for resistor. We have VRMS for capacitor. We have VRMS for inductor. We have so many other voltage. You see that? We have so many other voltage. So it's important you write this as VRMS for source. VRMS for source, so you don't confuse. Okay. Okay, and then this is resonant frequency, power dissipated. Okay, what is power dissipated? Power dissipated, or we call it power loss. Power loss is power average. This is power average. Understand? Power average is also called power dissipated. Okay. Power loss is 25 watt. Okay. This is IRMS square R. Okay. So we got all this value. Now we want to find inductance. What is inductance? Inductance is L. Not XL. Not XL. Not XL. Yeah. XL is called inductive reactance. But this one is inductance. Inductance is L only in Henry. Okay. And then resistance is R lah. We need to find R. Okay, so I think we do question A first. Okay, we have the capacitor already. Okay, normally if we give you this capacitance, I think you straight away find XC. XC is what the formula for XC? Formula for XC is 1 over omega C. Okay, 1 over omega C or 1 over 2 pi FC. That's the formula. Straight away find this first. Okay, that's the first step. As I told you before, refer back to my previous video. I told you about the step. These steps. Always find XC, XL, R first. Then you can find Z. Then you can find the rest. Understand? This is our preliminary steps. Okay, XC, XL, and R. Find that first. Okay, before the next thing. Okay, we find XC first. XC is 1 over omega C or 1 over 2 pi FC. Okay, so 1 over 2 pi FC. So okay, 2 pi F. What is F? Frequency. Where do you have frequency? Oh, this one is okay, never mind. I have the frequency. Use the resonant frequency first. Yeah, so this one is in resonant frequency lah. Yeah, we label this frequency as resonant frequency. It is using resonant frequency, so we put it as resonant frequency 1.3 kilohertz. Kilo need to change to exponent 3. Okay, 1.3 kilo is exponent 3. Exponent 3. Change to SI unit, kilo. Then the capacitance is 5.1 microfarad. This one also need to change the micro. Micro is exponent negative 6. Exponent negative 6. Micro, negative 6. And then this one become farad already. Okay. So what's the answer? Let's calculate. Calculate the answer. 2 pi multiplied by 1.3 exponent 3 multiplied by 5.1 exponent negative 6. Okay, calculate, and then 1 divided by answer. So the answer for XC is 24.00 24.005 ohm. The unit for XC is unit for XC is ohm. Okay, I got the XC already. Now I want to find resonant frequency. Okay, let me talk a little bit about resonant again. You also can refer back my video. For resonant, when resonant happen, you achieve resonant frequency. Yeah, how do you achieve resonant condition? Is you adjust the frequency into resonant frequency. You adjust the frequency into resonant frequency, then you get the resonant condition. Okay, because we know we can adjust the resonant frequency, we can adjust the frequency value to make what? To make we can adjust the frequency value so that the XL and XC can be changed. Because why? We can adjust the frequency value, so that XC and XL value can be adjusted. We adjust the frequency value into resonant frequency. When resonant frequency achieved, then these XC and XL value can be changed until they become equal to each other. XC and XL become equal. You see that? And resonance can happen. So okay, let me go continue back. So when resonant frequency achieved, this is the thing happen. Okay, this is the thing happen. Okay, let me draw the phasor diagram again. So when resonant happen, or when frequency become resonant frequency, then the thing is, okay, I want to draw, first of all, I want to draw the current first, IRMS. Okay, where is the resistor? The resistor is always in phase with current. So when resonant happen, the most important thing is when resonant happen is the XL become XC, become equal to XC, and they can cancel to each other. Understand? XL become XC. Why they can cancel each other? Because they are empty phase to each other. So this resonant happen. This XL and this XL, and we know that XL is always at the top. Resistor is always with the x-axis, and XC always at the bottom. So when resonant frequency happen, this XL and XC become equal length. They become equal length, and since they are anti-phase to each other, they can cancel. They can be cancelled to each other. So the total impedance will be equal to the resistor itself. The R become the Z become R, because we don't have this component anymore. The Y component already completely cancel off. So we only have the X component. So this X component become the impedance. Understand? And this impedance, it is at the minimum value of impedance. So when we talk about the form, okay. So we can say the Z is at minimum, is at equal to resistance. Okay. And then when we talk about the formula VRMS, when we talk about VRMS source, I equal to IRMS. When we talk about V source, it is equivalent to Z, isn't it? Equivalent to Z. So I can say that the Z is at minimum. So it is at the minimum value. So the current will be maximum. Current will become maximum. Understand? So when Z is minimum, then the current become maximum. Understand? When the impedance is minimum, the current become maximum. Understand or not? Because when Z minimum, when Z decrease, I increase. the IRMS increase, current become maximum. Another thing is, you can see here we don't have the phi value becomes 0. The phi value becomes 0 degree. Phi value becomes 0 degree, and we can say this. What is phi value? Phi value is the phase angle. We can say phi value is 0 degree. What is phi value? Phi value is the phase angle between V source and current, or V source is the Z, current is like the R, understand? So you see that the angle between V source and current becomes 0 at resonant. Okay, because why? Because see, Z is also with resistor, so the V source, this Z represent V source. Z represent V source. You see that? Z represent V source. So V source is in phase with current. See that? V source in phase become in phase with current. Yeah, V source become in phase with current. When V source in phase with current means the phi becomes 0. The phase angle becomes 0. The phase angle becomes 0 because the V source is in phase with current. Yeah, Z represent V source, so V source in phase with current. And then another thing is the power factor. Talking about power factor, what is power factor? Or we put it as PF, power factor. Power factor is cos phi. Now phi is 0. Phi is 0 means what? Means it is power factor cos 0 degree. Cos 0 equal to 1. Cos 0 equal to 1. Phi is 0 degree. Phi is 0 degree, so cos 0 is 1. So power factor is equal to 1. So these are the important thing for resonant, and I hope you remember this. All these are important notes for resonant. Okay. Okay, so now let's continue our lesson. So now have I get the inductance yet? Not yet, but I got I teach you about resonant already. So XL equal to XC, isn't it? Resonant frequency. This one is in resonant condition. So at resonant condition, XL equal to XC. I got the XC value. I can find XL. So okay, let me write. So question A. Okay, at resonant, this XL equal to XC. So I already got the XC value. XC value is 1 over omega C, which is 24.005. Okay. So okay, omega XL. What is the formula for XL? Formula for XL is omega L. Okay. Formula for L is omega L. XC formula is 1 over omega C. 1 over omega C. But this part, okay, never mind. Okay, omega is 2 pi FL, and 1 over omega C is 2 pi FC. And of course, this one is using the resonant frequency. Okay, this frequency is at resonant. Okay, frequency is at resonance, so it's FR. But this part I no need to do. 1 over 2 pi FC I no need to do because I already done it. I already done the formula. I got 24.005. I just substitute into that. Yeah, into it. So I just substitute into it. I just substitute because I already found it. Yeah, earlier using the resonant frequency. I already got 24.005. So I just substitute 24.005 ohm over here. And then this one, I need to find inductance, right? L value. So, okay. So, 2 pi resonant frequency, I need to put back. Resonant frequency just now is 1.3 kilohertz. 1.3 kilohertz. So, okay, put the value 1.3 kilohertz. Kilo exponent 3. Kilo is exponent 3. Okay, and then okay, and then L, I need to find the L, inductance. Okay, L. So let's calculate 24.005 and then divide by the 2 pi, and also divide by is 1.3 exponent 3, and I get what value? Yeah, the inductance is 2.939. 2.939 exponent negative 3 Henry. Okay, so that's the inductance, 2.939 exponent negative 3 Henry. Okay, so that's the inductance. Am I right? 2.94 exponent negative 3 Henry. I'm correct. That's answer correct. Okay, that's the answer. Am I correct? Okay, that's resonance. Okay, then how about resistance? How to find the resistance value? Okay, at resonance, the resistance value should be equal to the impedance Z. Be equal to the impedance Z. So I have the root mean square voltage VRMS source, right? I can make use of that value. Okay, so let's do it. Yeah. Question B. So we are still in resonance, right? Resonance. So we can I think we have the VRMS source, right? VRMS source. I think we can use the formula VRMS source equal to IRMS Z. Okay. So VRMS source equal to IRMS Z. Okay, IRMS Z. Okay, so I don't think I can continue, but I have okay, I don't have the current, right? I don't have the current. Okay, but I have another value here, power average. I have another value here, power average, which is the 25 watt. Power average 25 watt. Okay, let's write down the formula also. Power average is 25 watt. Power average or power loss, yeah. Power dissipated is power average lah, yeah. Power dissipated is power average. Power dissipated is power average. Power average is 25 watt. 25 watt, yeah. 25 watt. I think this will be helpful. Okay, power average formula is IRMS square R. If you look back to my summary sheet, power average is IRMS square R. Power average IRMS square R. So this might be helpful. IRMS square R. So IRMS square R equal to 25 watts. Okay. So I think here we can find the current. Resistor value given or not? Resistor value, oh, not given. Okay, so how? We need to find the resistance, isn't it? We need to find the resistance. Okay, but I don't have the current, right? So okay, never mind. I have two formula. I have the VRMS source, right? 11 volt. I should write it down first over here. This is VRMS source. This is 11 volt. 11 volt. Okay, so that's how you do this physics question. You know, you need to understand the question and then you figure out several formula that might be helpful. VRMS source is 11 volt. 11 volt. So that's IRMS Z. Because V source responsible for impedance, you know. the voltage for everything, responsible for impedance of everything. The voltage for everything, voltage from the source is voltage for everything, is responsible for the load of the whole circuit. The load for the whole circuit is impedance. Understand? Okay, that's V equal to V RMS source equal to I RMS Z. Okay. Resonant. Remember resonant? The impedance is equal to R. The impedance is at minimum. It is equal to the resistance. So we can substitute this Z is at minimum. This Z is at minimum. Why minimum? Because the XL and XC already been cancelled off. So what's left is only the resistance. So the resistance become the impedance. So this Z minimum is R. We can change it to R. So change it to R. So this is I RMS R because it at resonance. Understand? This Z become R because at resonance. Okay, so we have IR equal to 11, I square R equal to 25. So what do you think? So what I can do is, this is the two formula. This is formula 1, this is formula 2. What I can do is I just divide. Why not? I divide. So I can use the 2 divided by 1. 2 divided by 1, which is I RMS square R divided by I RMS R. Okay, which is 25 divided by 11. 25 divided by 11. Okay, 25 divided by 11. Okay, yeah, I can cancel. The R cancel, the I RMS and this one's cancel. So what left is the I RMS. What left is the I RMS. So let's calculate. So I RMS equal to is 25 divide by 11, which is 2.273 ampere. So I got the I RMS. 273 ampere. Yeah, I got the I RMS. So is the I RMS helpful? I want to find resistance. Of course, no problem. I just substitute back and I get the resistance. You understand? I will get back the resistance. So okay, let me calculate. So this I RMS just put back into here. I RMS put back into equation 1. Put back into equation 1. 11 equal to I RMS R. This I RMS is 2.273. I can get my resistance. Okay, I can get my resistance. So let's calculate. 11 divided by 2.273. It is 4.83. I just put 4.84 ohm. 4.84 ohm. 4.84 ohm. Okay. 4.84 ohm. 4.84 ohm. Okay. 4.84 ohm. Let's check my answer. Resistance 4.84. Is it correct? Oh, jackpot! I got the answer correct. 4.84 ohm. That's correct. 4.84. 4.84. 4.84. That's correct. This is a good questions. Okay. 4.84. That's how you do it. I got the RMS, the RMS current, and also the resistance 4.84. Okay. So done. You got the resistance already. Important thing, you must know this thing, this concept. Yeah, this whole thing. And then now, question C. This is not resonant anymore. Not resonant anymore is another frequency and it's not resonant. 2.31 kilohertz. So generator frequency. What's the power factor? So what is power factor? power factor is cos phi. You need to give me the value of cos phi. Okay, for this frequency. Okay, so question C. Let's do question C. Okay, question C. Now the frequency has become 2.31 kilohertz. Frequency has become 2.31 kilohertz. Kilo, I need to change to exponent 3 lah. Yeah. Okay, this is not resonant anymore. Yeah, this is not resonant frequency anymore. Not resonant frequency anymore. Okay, so that means when not resonant frequency, this XL not equal to XC anymore. Yeah, not equal already. They are not equal anymore. Because not resonant, not equal anymore. Things has changed. Things has changed. So what you have to do is, I can say these two value has changed. When frequency change, when this frequency changes value, this XL and XC all also changes. All also changes value. Only one thing is constant. Yeah. Why we can say XL and XC changes? Because XL is the formula 2 pi FL, and then XC is 1 over 2 pi FC. So when the frequency changes, XL and XC also changes. Understand? Remember this formula. XC is 1 over 2 pi FC, XL is 2 pi FL. So when frequency changes, XL and XC changes. That's why when not resonant frequency anymore, XL and XC, they are not equal. Okay, because frequency changes, XL and XC also changes because they are dependent on frequency value. They are dependent on frequency value. Only one thing is constant. The resistance remains constant because resistance don't have a formula. And just now we got the resistance value is 4.84 ohm. This one is still constant. This one is still constant. But we can say that the XC, the XL is no longer. Do we have the XL? XL, XC. You see that? XL is not XC. XL is not 24.005. And XC also not 24.005 already. Yeah, because it changes already, because the frequency has changes value. You need to find the new value already. Only the resistance is constant. This one constant. XL and XC not equal. That means they are not. Just now you got XC is 24.005. This one only happen when resonant frequency. Understand? Only happen when resonant frequency. So once frequency changes, once frequency changes to new value, so the XC is no longer 24. No longer 24. XL also no longer 24 because this one just now resonant is XL equal to XC. So both of this XL and XC is 24.005. Now the frequency changes. They are not 24 ohm anymore. They are not 24 ohm anymore. Understand? Only resistance is constant because it has no formula. It's constant. Yeah, I can say it is independent. Only resistance is independent of frequency. This XL and XC, they are dependent of frequency. Understand? Only the resistance is constant because it's independent of frequency. Okay, so now what's the question? Power factor. Okay, power factor. That means power factor is seems like a lot of things to do. How to do? What is the best way to do the questions? Okay. Since you have a new frequency, I think you need to find a new XL and XC already. Yeah. I think I need to find the new XL and XC to find the power factor. Yeah, power factor. So okay, I think I need to find the new value of XL and XC. So find XL first. XL is what is XL? XL is omega L or 2 pi FL. Okay, omega L or 2 pi FL. Okay, so I need to find the new value of XL. So new value of XL just now is 2.31, isn't it? 2.31. Okay, so it's 2.31 exponent 3. Okay, new frequency. The inductor L. What is the inductor L? Inductor L. This one is constant lah. L is constant, but XL is different. L is 2.939 exponent negative 3. Okay, so okay, let's calculate. 2 pi multiplied by 2.31 exponent 3 and multiplied by 2.939 exponent negative 3. So the answer is XL is 42.657 ohm. You see, different. XL is no longer 24, it's 42 already. 42. How about XC? Let's find out XC. XC, what is XC? XC is 1 over omega C or 1 over 2 pi FC. So let's calculate the new SC. New XC is 2.31 exponent 3. 2.31 exponent 3. C, what is the C value? What's the C value? Do I have the C value? C value, yeah, 5.1 microfarad. 5.1 microfarad. So 5.1 micro is negative 6. Change the micro into value. Change the micro into value. Okay, so I got my new value of XC, which is, let's calculate, 2 pi multiply 2.31 exponent 3 multiplied by 5.1 exponent negative 6. So it's 1 divided by answer. So the XC is 13.5095. Yeah, 13.5095. Okay, so okay, so that's the XC. So see, different already. They are not equal already. See that? XC and XL, they are not equal. They are not equal. They are not equal because not resonant. They are not equal already because they are not resonant. Okay. So okay, so what need to draw the phasor diagram if you want to find the power factor. You want to find the power factor, you need to draw the phasor diagram. Draw again the phasor diagram. Let's draw the phasor diagram. Okay, power. Okay, so first of all, I draw the IRMS, and then I draw the resistor. This is RCL circuit, right? This is RCL circuit, right? RCL circuit. So it has everything. It has everything. It has resistor. First of all, it has resistor. And then XL, okay, XL is always at the top, XC is always at the bottom. But then you need to see which one longer. This one is this one bigger, this one smaller. Okay, so XL you must draw longer. XL you must draw longer. XL is always at the top. XL is always at the top. XL is at the top. XC is at the bottom and it is smaller value, so you need to draw XC shorter. XC shorter. Yeah. Why is it XL at the top, XC at the bottom? All because of I's and the capacitor is I's and then the inductor is LE. I don't want to explain any more about I's and LE because I already explained a lot in my concept video and in my other videos. Yeah. Why is it XL at the top? Why is it XC at the bottom? I think you already understand. Yeah. So XC always at the bottom, XL always at the top, resistor always with current. Okay. So this is the new. You see, XL must be longer, XC must be shorter based on the value. Okay, you must draw like that. Based on the value, you can see XL is bigger value, so you must draw XL longer. XC is smaller value, you must draw XC shorter. If you found that XC is longer, bigger value, then XL is a smaller value, then you will need to draw XC longer and then XL shorter. The other way around. Okay, if you found that XC is bigger, XL smaller, then you must draw XC longer, XL shorter. Then the impedance will be at the below. But this one is XL bigger, XC smaller. So XL bigger, the top one should be longer. XC is shorter. So the impedance will be, the impedance will be at the top. Because after cancel, XL and XC cancel, there'll be after XL cancel by XC because they're antiphase, then the Z will be at the top. Why is it the Z at the top? Why is it Z at the top? Because XL longer. XL longer, so XL minus XC, we still have the remaining not cancel at the top. That's why Z is at the top. If XC is longer, then Z is at the bottom. Understand? Good. Now later you need to find the phi. You need to find the phi. The power factor. The thing we want to find, the power factor. The question want to find power factor, isn't it? Power factor at this frequency. The power factor is cos phi. Cos phi. So the power factor is cos phi. Cos phi. So to find the power factor cos phi is we use the what? R over Z. Is R over Z. That's why I put in my summary. Power factor is cos phi. And you need to draw the phasor diagram first. Draw the phasor diagram first. Then you got the phi already. Then you find the cos phi by using R over Z. R over Z. Get the power factor. So power factor is cos phi, R over Z. Why R over Z? Why is it R over Z? Because R is the adjacent, R is the adjacent and Z is the hypotenuse. It's Pythagoras theorem. Yeah, it is over adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent over hypotenuse. That is power factor cos phi. Okay. So okay, I can. Do I have the Z value first? Do I have the Z value? I don't have yet. So I need to calculate the Z value. I need to find the Z value. So the Z value is not R anymore. Yeah, because it's not resonant. It's not resonant. So the Z is not R. The Z is, you need to calculate using the Pythagoras theorem. So I got the XL and XC value, right? I got the XL and XC value. So XL minus XC. So is actually XL minus XC, this one square, plus the resistance square. Okay. So okay, let's put in the value. XL is what? XL is 42.657. And then minus XC. XC is what? XC is 13.5095. And then square, and then plus resistor. Plus resistor. Resistor is 4.84. Resistor is 4.84. 4.84. Okay, 4.84 square. Okay. So okay, resistor 4.84. Okay, so that's correct. Okay. So calculate first. 42.657 minus 13.5095, and then square, and then plus 4.84 square, and square root the answer. I got the Z is 29.29. 5466 ohm. That's the impedance. I got the impedance already, 5466 ohm. Okay, so now I can find my cos phi, my power factor. Cos phi is my power factor. Use the adjacent or hypotenuse. So okay, so what is my resistance again? My resistance value just now I got is 4.84, right? 4.84. Wow, this question is challenging, man. So it's 4.84 over z. Challenging but not impossible. If you do it carefully, detailed as me, you can get the answer. Okay, that's the cos phi, that's the power factor. Okay, so 4.84 divided by r over z, adjacent over hypotenuse. That's cos phi. 2 point. Okay, so let's calculate and see. 4.84 divided by 29.5466 is what answer? It is 0.16. That's the answer. No unit. Okay. No need to anti-cos. Understand? Anti-cos. If you want anti-cos, that's phi. That's the phase angle. That's the phase angle between current and V source. That's a phase angle. That's a different thing. That's not power factor. That's not power factor. That's phase angle. That's phase angle. Okay. If you anti-cos the 0.16, that's phase angle. Okay, phase angle. Let's calculate and see. So the phase angle is the phi phase angle is 80.57 degree. That's phase angle. That's different thing. That's different thing. That's not we want to find. That's not we want to find. Okay, what we want to find is just this one, the cos phi. Just the cos phi. Understand? 0. Phase angle is you anti-cos already. That you get a phase angle between current and voltage. But our power factor is just 0.16. Okay, and no unit. So is the answer correct? 0.16. Whoa, I'm correct again. It's jackpot again. Okay. 0.164. That's correct. 0.164. That's correct. So my answer is 0.16. 0.16. That's correct. Yeah, my answer is correct. Okay, so that's all for these lengthy questions. Yeah, it's a bit challenging, but it's not impossible. If you have all the details like me, you can do it. Okay, don't you like this type of questions? Yeah, it's you learn a lot of things. Yeah, if you know how to solve such questions, you can consider you will be satisfied. The feeling is you feel satisfied if you can solve this kind of questions. Yeah, so that's it. That's all for these questions. Okay, I hope you understand. Okay, that's it. Okay, bye bye.